I'm going to show you how to balance equations. When you open this assignment, please make sure that you click on this link and go to the simulator in order to practice balancing equations. It's a little bit easier to have something to manipulate. And you can change the tools option so that you can see your work a little bit more easily. Once you've had a chance to play with the simulator, then come on back here and we'll try this together. So some things to keep in mind. Each element is represented as either a single capital letter, like in potassium, or as a capital letter and a lowercase letter, as in magnesium here. So as you're looking, each capital letter is going to represent a single atom. So here we have an atom, here we have an atom, here we have an atom, this is an atom, this is an atom, and this is an atom. So let's jump in. So the whole point of balancing equations is to make sure that we have the same number of atoms before the reaction as after the reaction. Now during the reaction, those atoms are going to rearrange themselves. They're going to break bonds and reform bonds, but the atoms cannot be created nor destroyed. So the atoms that are present at the beginning have to be present still at the end. So we're going to balance the equation by counting how many are going in and how many are coming out of the reaction and change the molecules accordingly. So as we get started, we're going to take a look for the arrow. The arrow shows the reaction is occurring, and we're going to, again, be counting everything before the reaction and after the reaction. And so we can find this arrow, and the easiest way to divide the two is just to put a line right there. So find the arrow and draw a line straight down. And then we're going to count all of the atoms of each different type of element on the reactant side and on the product side. So the first one that we see over on the reactant side is potassium. So we've got a K. The next is magnesium, Mg. And the next is Br, bromine. And we have the same atoms on the other side, even though they've been rearranged, K, Mg, and Br. So if we count how many, as we're looking at the blank in front, this is the coefficient. This tells us how many pieces of this we have. And if there's nothing, we can assume that it's just one. So as it is right now, we have one potassium as a product, or as a reactant. Taking a look at this, there's only one magnesium in this molecule. So we've got one here. And Br2 indicates that there are two bromine in this molecule. So on this side, to start the reaction, we actually have two atoms of bromine. On this side, we have one atom of potassium, one atom of magnesium, and one atom of bromine. So we have one potassium to start with and one at the end, one magnesium to start with, one at the end, two bromine to start with, and only one at the end. So this cannot be, because this bromine can't just disappear, and we need to account for where it went. So we're going to change the numbers of the species, or the pieces and participants in this reaction, until we can balance these numbers. And so if I have two here, and the easiest way to make this a 2 is to say, okay, well, instead of there only being one of these, there are two of these. And if there are two of these, well, then we have two bromine. But if there are two of these, then we also have two potassium. And so we're still out of balance. So the way we can fix that is to come on over here and say, okay, well, there's just two potassium. So 2 potassium reacts with 1 Mg2Br to form 2 KBr and 1 magnesium. Everything equals, everything is balanced. Let's take a look at another one. We're going to find the arrow and just draw a line straight down, and we're going to take a look at what atoms are in this reaction. Well, I see an Na, I see a Br, I see a Ga, and I see a Cl. Same on this side. So let's count what we have to start with. I see just one sodium atom over here, one bromine, one Ga, and this 3 attached to the Cl means there are 3 Cl in this molecule. So I have 3 Cl atoms to start with. On this side, ending after the reaction, I have 1 sodium. I have 3 bromine. This 3 means that there are 3 bromine in this reaction. I have 1 Ga, and I have 1 Cl. So we are out of balance. So it doesn't matter if we make an adjustment to balance the chlorines, or if we make an adjustment to balance the bromines. Doesn't matter which one we do first, we'll end up with all of them balanced by the end. So let's take a look at the chlorine. How would we balance out the chlorine? Well, we could, if there's 3 on this side, we could just say that there are 3 sodium chlorides over here, and that means that we have 3 chlorine atoms accounted for. But that also means that we now have 3 sodium atoms. And so we are still out of balance. But if we go over here and we say instead that there are 3 sodium bromides, that means that there are now 3 sodium atoms, and that takes care of our bromine atoms as well. 3 sodium in, 3 sodium out, 3 bromine in, 3 bromine out, 1 gallium in, 1 gallium out, and 3 chlorine in, 3 chlorine out. Here's the part where you get to start to try. So remember to set up your balancing. You're going to just draw a line down underneath your arrow, and you're going to count the number of aluminum and bromine atoms on each side. Don't forget to take a look at the subscript. The small number after an element symbol tells you how many of that element are in each atom. If I was going to draw AlBr3, I'll have 1 Al, and I will have 3 Br. This could represent AlBr3. It tells us that there are 3 bromine in this whole molecule. So, happy balancing.